Hi everyone, today we're going to take a look at lesson 6-5, operations with radical expressions. So we're going to be looking at rationalizing denominator, like radical expressions, conjugates. So the property of radicals, the product property of radicals, pretty much is saying that I could break up this radical into two different radicals, if they're multiples. So for any real number a and b and any integer for n greater than 1, we have the nth root of ab is the same thing as saying the nth root of a times the nth root of b if n is even and both a and b are both non-negative or if n is odd. So for example, the square root of 2 times the square root of 8 is the same thing as square root of 16 because 2 times 8 is 16. And this would be easier for me to know that the square root of 16 is 4. Same thing here, cubic root of 3 times cubic root of 9. I can do 3 times 9, which is 27, and 3 is the cubic root of 27. So I'm going to go ahead and simplify the square root of 25a to the 4th, b to the 9th. So we need, for this to work, we're going to break them into factors. We know the square root of 25 is 5. The square root of a to the 4th is going to be 2a squared. And b to the 9th, since 9 is not even, it's not a perfect square of a variable. So we can break this up into saying it's 25 times a to the square root of a 24th. Oh, let me write this out. That might be easier to see that way. So I probably would write this as the square root of 25 times the square root of a to the 4th times the square root of b to the 8th times the square root of b. Because I can do these three here. And this is an 8. Which would be getting me 5a squared b to the 4th square root of b. We're going to take the cubic root of 125, m to the 30th, p to the 20th. And pretty much what I would always check and see is if these exponents are divisible by 3. If they're divisible by 3, I know I'm fine. And what you can also think of this as, when they do this here, this cubic root of 125 is 5. The cubic root of m to the 30th is 10, because 30 times 3, divided by 3 is 10. You can think of doing division that 20, if I divide by 3, I get 6 with a remainder of 2, because I do minus 18 and we get 2. The 6, our quotient here, 6 would be my outside exponent. My remainder would be my inside exponent. All right, go ahead, pause the video to give yourself time to try this one. All right, and you should get A. Pause the video to give yourself time to try this one. All right, you should get C. And we do need absolute value symbols because our nth value is even and our resulting exponent is odd. K to the 5th does not need one because there's still a k value here inside the cubic root, or the 4th root. Quotient property is pretty much the same. The only difference is that we're using division instead of multiplication. So the nth root of a over b is the same thing as taking the nth root of a over the nth root of b. All right, so we're going to head simplify the square root of y to the 8th over x to the 7th. So we're going to head and separate these using quotient property. We're going to factor into squares and use product property. And we're going to rationalize the denominator. So one of the things is we do not like having square roots in the denominator. So when we do this, we get y to the 4th square root of x all over x to the 4th. All right, we're gonna take the cubic root of 2 over 9x. We're gonna use quotient property, and we're gonna head and rationalize the denominator. You need to multiply using the same root, and then multiply what would it take to get the inside of this the radicand here to be a perfect cube is what you're gonna multiply by. So using product property, we get the cubic root of 6x squared over the cubic root of 27x cubed, which gets us the cubic root of 6x squared all over 3x. And that would be our solution. Pause the video to give yourself a chance to try this one. All right, you should get C, x times the square root of xy over y to the fourth. All right, pause the video to give this one a try. All right, you're gonna get C. So here is a checklist for simplifying radical expressions. The index n is as small as possible. The radicand contains no factors other than 1 that are the nth powers of the integer or polynomial. The radicand contains no fractions, and no radicals appear in the denominator. So we're going to go ahead and multiply radicals. So we're going to use product property. And to simplify, we're going to just see if we can write them as cubes, which we can. In this case, we get simply 50a, because you're going to multiply like with like. All right, go ahead and try this one. All right, so what we're going to head and get here is B24a. All right, so we can add and subtract radicals for this to happen. Generally, we'll try to simplify the radical first, meaning we have on the inside as prime as possible. So when we do this one, we get 3 times 3 square root of 5 minus 5 times 4 square root of 5 plus 4 plus times 2 square root of 5. So we notice that inside the radicals, there is a perfect square times 5, which is what they did here. And now that they all have the same radical, you kind of can think of a radical the same as a variable. They have to have the same radical with the same radicand for me to add or subtract them. And when we do this, we get negative 3 square root of 5. All right, go ahead and try this one out. All right, you should get D 8 square root of 3. All right, we can also multiply. So they're going to use FOIL here. Generally, we will just use the box, and we have the same properties would apply here. They did first, outer, inner, last. We typically stay away from FOIL just because it only works with 2 binomials. But they did they did 2 cubic root of, or 2 square root of 3 times 3, 2 square root of 3 times negative square root of 3. Then they did 3 square root of 5 times 3, and then 3 square root of 5 times negative square root of 3. And it is okay to have multiple as an expression, 6 square root of 3 minus 6 plus 9 square root of 5 minus 3 square root of 15. Completely fine. There's not really a right or wrong way to order these. Sometimes it's just by preference. So go ahead and pause the video to try this one. All right, so using either FOIL or box, you should get D, 10 square root of 5 minus 2 square root of 35 plus 20 square root of 6 minus 4 square root of 42. So when you multiply these, you should have saw that there was no common radical for you to combine. So in the square side with a, the ratio is given a over a square root of 2 minus a. So we're going to rationalize it by using a conjugate. A conjugate is pretty much very much the same. The only difference is you would multiply by the conjugate of the denominator. Same, but difference operation between plus and minus. So when they multiply, you'll notice that the square root will go away in the denominator. This is using the rule of a difference of two squares. So like a plus b times a minus b will get you a squared minus b squared, which is what happened here. We have 2a squared minus a squared. So we can factor out the GCF. And simplify, we get the square root of 2 plus 1 all over 1, which is just the square root of 2 plus 1. All right, pause the video to try this one out. All right, you should get b, square root of 3 minus 1 all over 2. And that is the end of our lesson for 6-5. I will see you next time. Bye.